Alright guys, so this is the intro video to 7.2 Systems in 3 Variables. What we've been working on so far were linear systems in 2 variables. So what we had were a system of 2 or more equations, and what we were looking for was the point of intersection. So that point of intersection happened at some point x, y, and that was the solution to the system. You would use either graphing, substitution, or elimination to solve for it. So we're going to use a combination of system and elimination, use a combination of substitution and elimination to solve systems in 3 variables, but I want to kind of introduce you to what that means. So when you have 2 variables, we have a linear system, right? So this, you could solve for y and you'd get, y equals mx plus b, and then you would, plot your line and solve it, or and graph it. When you have a system in 3 variables, you have something like this. We're working in 3 dimensions, so you would have something like x, y, and then z, which is now a 3rd dimension. So if you have something like 3x plus 4y minus 5z equals 12, you no longer have a line. You have a plane. So instead of having, a line that looks something like, like that through your x and y, you actually have like an entire plane that crosses through all 3, of those lines. So now when we have a system in 3 variables, so say you have 2x plus 5y minus z equals 3, and I'm just making these up, and 5x minus 2y plus z equals 1, what you're actually doing is you are finding the line in which all 3 of those planes intersect. So say that's, I'm going to label this A, B, and C. This could be A here. You could have a 3rd plane, that comes out, something like that. That would be B. And you could have another plane here. And I'll go over this a little bit more in class. Okay, so what you're looking for is the line of intersection where all 3 of them cross. Okay, and that's a line in 3 variables. Now, when you had the intersection of 2 lines, your solution was a point x, y. Well, it's also going to be similar to this, but it's going to be the line x, y, z. That's going to be your solution. You're going to write it as a point. It's always going to go in order x, y, z. And that's just how you plug it in. I know you guys probably can't see that. So it's your solution is the point consisting of 3 variables x, y, z, and it's actually a like a line that we're finding. And like I said, I'll go over this in class when I see you, but just so you kind of can have a visual of what is going on. So this video is pretty simple. What we're going to be doing is checking to see if a solution or if a line here is a solution to the system that's given. So in the same way, when we had a system of 2 variables and our point was x, y, we would plug it back into the system to check our work. That's the process that we're going to take here. So I have an example for you, and I'm only going to do one because it's not very complicated at all. So the question is x equals 6, y equals -2, and z equals 5 a solution to this system here? So all you're going to do is plug in your numbers again and look for true statements. So we have x minus y plus z is equal to 13. And just plug them in. So 6 minus -2 plus 5, and then simplify. Have a double negative there. So 6 plus 2 plus 5. 6 plus 2 is 8. 8 plus 5 is 13. So yes, we have a true statement. So this is a solution to that line there. We'll try the second one. 2 times x plus 5 times y minus 3 times z is equal to -13. plug in your values, and simplify. 2 times 6 is 12, 5 times negative 2 is negative 10, negative 3 times 5 is negative 15. 12 minus 10 is 2, minus 15 is equal to negative 13. So another true statement, which means it's a solution to this here as well. And then we'll do the last one. 4 times x minus y minus 6 times z is equal to negative 4. Plug in your values and then simplify. So 24 plus 2, you have a double negative there, minus 30. That's 26 minus 30. And you can see that we'll also have another true statement here. So if all three of them check out, then you can say yes. Okay, yes. It is a solution to this system here. And that's all we're doing, guys. You can go ahead and jump on to the next video, which is actually solving the systems, which does get a little complicated. But other than that, if you have any questions, let me know. Shoot me a remind or ask me when I see you in class.